Hi guys, welcome to Lesson 2.8, Proportions and Similar Figures. Our objective for this lesson is that I can find the missing length in similar figures, and I can use similar figures when measuring indirectly. Our essential understanding is that you can use proportions to find the missing length in similar figures, and such figures can help you measure real-world distances indirectly. So we have a couple vocabulary terms today. First of all is similar figures. These are figures that have the exact same shape, but they are not necessarily drawn to the same size. A scale drawing is a larger or smaller drawing similar to the actual object or place. For example, a map. And a scale is the ratio of any length in a scale drawing to the corresponding actual length. So we will see those a little bit later on. First of all, we have problem number 1, finding the length of a side. Now, when shapes are similar, we say that their corresponding angle measurements are equal and their corresponding side lengths are proportional. So the first thing we need to do is identify which are the corresponding sides and angles in our quadrilateral cats and doggy. So in cats, the side CA is going to be corresponding with DO. The side AT corresponds with OG. Angle A corresponds with angle O. Angle T corresponds with angle G. So angles A and O are going to be identical. T and G are identical. And the sides AC and DO are proportional. You'll also notice that the order that they are named is the order we go around the shape. All right, so that'll lead you to some ideas. All right, the figures are similar, we're being told that, and we want to know what is the missing side. So we can use proportions to set this up. So I'm going to say y over 32 is equal to 45 over 36. Y is proportional to 32 as 45 is proportional to 36. So to go ahead and solve this problem, we're going to multiply both sides of the equation by 32. And we find that y is equal to 40. So 32 times 45 divided by 36 is going to be 40. All right. So, pretty straightforward. I know you guys have done a lot of this last year using scale factors in 7th grade. So go ahead and give problems A and B a try, and we will check back with the answers. So for problem A, I'm going to write my scale factor. I want to know what is the side length of DE, so I'm going to call that X. So I'm going to say X over 10 is equal to 12 over 16. So I pick two corresponding sides. I have the one unknown, the one known, and then I have another corresponding side that we can use. Multiply both sides by 10. And X is going to be equal to 7.5. All right, letter B. What is AC? So I'm going to use the letter Y to represent AC, and its corresponding side is DF. So I'm going to say Y over 18 is equal to, I'm going to use one of the sides that we are given in the problem, just so I don't make any mistakes, 16 over 12. Okay? And when you do the math, we are going to multiply both sides by 18. And y is going to be equal to 24. Now, you will notice that I yell at you guys all the time that you need to put units on your answers, and I didn't put any units on my answer. Well, the reason for that is we were given no units in any of these problems. We're just given dimensions on some shape. We don't have any units that we can apply. Okay. Problem number 2, applying similarity. So this is where we're going to do that indirect measurement. So you've been asked to find the height of the tree out back. You set up the following contraption and made a few measurements to get the diagram below, and we want to find the height of the tree. So you can't exactly climb up the tree with a measuring tape measure and see how tall it is, but we can use its shadow length and a proportional shadow to see what the height of this tree is actually going to be. So I see I have two similar shapes. They're both triangles that have shadows. So I can say that 1 over 0.6 is equal to x, our height, over 4.8. Okay. And now we are going to multiply. So we need to multiply both sides of our equation by 4.8 to get our x all by itself. So x is going to equal 8, and our unit is meters. Okay. Now, could you also set up your proportion the way I did before, where I have one piece from each side? You can. You have x over 1 is equal to 4.8 over 0.6. And when you simplify, you are going to get 8 meters. Either way is a correct approach. So now we have letter B. A man who is 6 feet tall is standing next to a flagpole, and the shadow of the man is 3.5 feet. And the shadow is 17.5 feet for the flagpole. The man is 6 feet tall. So let's start with a little bit of a drawing. So here's our flagpole. And here's our man. And he's happy. All right, so we've got our flagpole. We know that the flagpole's shadow is 17.5 feet. The man's shadow is 3.5 feet. And we know that he is 6 feet tall. And we want to know the height of our flagpole. So we can set up a ratio. We have x over 17.5 is equal to 6 over 3.5. And now we just need to multiply both sides of our equation by 17.5. And when we do the math, we find that x is equal to 30 feet. All right, so I want you guys to try letter C, and we will come back and go over the answer. So we have a student who is 5.25 feet tall standing next to a tree. The shadow of the student is 20 feet long, and the shadow of the tree is 80 feet long. We want to know what is the height of the tree. So let's start with our drawing. We have our tree. Can you tell I'm an art major? So we have a shadow that's 80 feet long. We have a person standing there, and his shadow is 20 feet long. And we know that he is 5.25 feet tall. So we can set up our proportion. X over 80 is equal to 5.25 over 20. Multiply both sides of the equation times 80. And x is going to equal 21 feet. All right. Problem number 3 is talking about interpreting scale drawings. So we have a map here with a ruler on it, and we are showing that the scale of this map says that 1 inch on the map is equal to 110 miles in real life. And so our question A is asking us, what is the actual distance from Jacksonville up here to Orlando down here in a straight line, or as the crow flies, as they say. So I'm going to set that up. The first thing I need to do is I'm going to set up my ratio that I already know, which is 1/110. And we're going to set that equal to, well, we don't know its actual mileage, so we're going to put x in the denominator there. And as we look at this ruler, we have quarter, half, 3/4, 1 inch, 1.25 inches. All right, so when we have a variable in the denominator, what do we need to do? I hope you all yelled out cross multiply at once. All right, so we're going to cross multiply. So x times 1 is x. 1.25 times 110 is 137.5. X is all by itself, so we've solved it. Miles. Okay. Now, letter B says the distance between Jacksonville and Gainesville, Gainesville's here, Jacksonville's there, on the map is about 0.6 inches. We want to know what is the actual distance from Jacksonville to Gainesville. So we're using the same map, so we have the same scale, 1/110 is equal to, this time it's 0.6 over x. Again, we are going to cross multiply. 110, our x times 1 is x. 110 times 0.6 is 66 miles. Okay, I want you guys to try letters C and D on your own, and then we will come back for the answer. So, if we know the actual distance between two cities is 250 miles, and the two cities are 2 inches apart on a map, how can we find the scale of the map? Well, I know one of the ratios right there is 2/250. Now, scales of maps are always reduced down to 1 inch being our reference point. So 1 inch is how many miles in the real world. So we start by cross multiplying, and we got 2x equals 250. And we are going to divide both sides by 2. So x is equal to 125. Miles. So 1 inch on that map is equal to 125 miles. Okay. Letter D, 1 inch represents 12 miles on a map. If the distance between two buildings is 4 inches, what is the actual distance? So 1 inch is 12 miles. We have 4 miles apart on the map, and we want to know how much that is in real life. So we cross multiply, and x is equal to 48 miles. Okay. Moving on to problem number 4, which is using scale models. So the difference between a map and a scale model is that a scale model is 3-dimensional, and a map is just a 2D surface. All right, so a giant model of a heart is shown above. The heart is the ideal size for a person who is 170 feet tall. About what size would you expect the heart of a man to be who is 6 feet tall? So as we can see in our model, the height of this heart is 14 feet. So I'm going to say 14 over 170 is equal to x over 6, right? The height of the heart on the giant man per its height is equal to the height of a regular man per his height. So now we need to multiply both sides of the equation by 6. And we get that x is equal to 0.49 feet, or just about 6 inches. Okay. Letter B. This summer, LEGO released the NASA Apollo Saturn V rocket set with a scale of 1 to 110. The actual Saturn V rocket that launched men to the moon in 1969 and 1970, 71, 72, and 73 was 363 feet tall. We want to know, how tall will the Lego model be when I finish building it? I haven't even started yet. So we have 1 to 110 scale, and we have 363 feet tall for the real thing. So we have 1 over 110 is equal to x over 363. Multiply both sides of the equation by 363. And you get that x is equal to 3.3 feet. So just about 1 meter tall is going to be this model when I finish building it. It also has 1,969 pieces to it. So 1969, year of the moon landing. Coincidence? Yes. Actually, no. It was intentional. All right. Letter C. A scale model of a building is 6 inches tall. The scale of the model is 1 to 150, or 1 to 50, and we want to know how tall the building is. You guys give these a try, and then I will go over the answer. So our model is 6 inches tall, and the scale is 1 to 50. So we want to know how tall the building is. If it is 1 over 50 is equal to 6 over x. So we need to cross multiply. X is equal to 300. Okay? 300 feet. Letter D, a model of a new campus building is 5 inches tall. If 1 inch represents 8.5 feet, how tall will the building be? So I start off, I've got 1 inch is 8.5 feet, which is equal to 5 inches over x feet. We don't know how tall it is. We are going to cross multiply. So we have x is equal to 8.5 times 5 is 42.5 feet. And that is the end of our lesson for today. Make sure you guys fill out your level of understanding and write down any questions you may have come up with along the way or any confusions you have. And then do make sure you write your summary of what you learned in this lesson. See you in class tomorrow.